Hey guys, I just wanted to give you at least one example of one of the vector calculations on this lab, just to make life a little bit easier for you. There's a few more questions than I expected, so yeah, let me just clarify this. So we'll take this humerus as an example. Okay, we're going to find the vector for this humerus, and then you guys can take it from here. Okay, so this humerus here will have a vector it looks something like that, right? I'm gonna put my little arrow on there, okay? And now I'm gonna go ahead and get some other colors here. Let's do red here. Okay, and then so this guy here, this little vector is gonna break up into two components. He's gonna break up into an x component. So like right there. Right? And then he's going to break up into a y component. Okay? Put our little arrows on those components. And so this is going to be, so if this is a humerus, we'll call it h, the h vector. Right? So this is going to be hx, and this is going to be hy over here. Right? But remember I said in the video that this doesn't have to be here. You could do it head to toe as well. So I can take this vector and just slide it over here like this. And now I have a right triangle. Okay, so this little vector makes a right triangle where the components, the hy and the hx component, are the legs, and then h is actually the hypotenuse. Okay, and now below the x-axis here, this vector has some angle. Okay, we'll call that theta. All right. Now that means that if I can just find my hx and hy components, right, then I have a vector for my humerus. That's going to be hx I plus hy j, right? And so you guys hopefully remember from last week, right, that hx, right, is going to be just the magnitude of this, h, cosine of the angle. The component that touches the angle always gets the cosine. Okay, so this is going to be h cosine theta. If you're ever not sure, just look. Does this component touch this angle? Is this component part of this angle? And that is yes. Is y part of this angle? No. Y is opposite the angle, right? And the component opposite the angle always gets the sine. And this little I doesn't have to be there yet. Okay? So that means that if I just measure h with my ruler, that's what I put in there, right? So measure h with the ruler, that's how you get the magnitude. And then measure theta with a protractor, that's how you get the direction. Okay, so you already have the magnitude and direction just by measuring these guys with your ruler and your protractor. Okay, and then, I don't know, it looks like about roughly 3 centimeters, so let's say 3, right? And this looks like roughly a small amount of degrees, so let's say about 10. So you could get something else, but I'm just going to estimate 10. 3 cosine 10 here, right? And this would be 3 sine 10. Okay, and you just put that in your calculator, make sure you're in degrees, not radians, and then you have your answers. And then whatever you get, you just put in here for your hx, right, plus I, plus your hy j. Okay, now once you put these in, you have to be careful about your signs, right? So notice this x component points which direction? Negative x, right? Negative x. So this has to be negative. Whatever you get here, you put a negative answer in here. Okay? And then whatever you get here for y, your hy component, that's also pointing down. It's pointing down in the y direction. So this also gets a negative sign over here. Okay? My really, really strong recommendation is that you don't measure your angle from positive x. So don't go like, oh, that's 180 plus 10, 190 there, right? Use what's called the cardinal angle, which means the smallest angle with respect to the x-axis, okay, and then use the direction that the vector's pointing to get the signs. It's much quicker, much easier, much simpler. You don't have to worry about big angles, and you'll always get the right answer because you can just look which direction is it pointing. Okay, just for for confirmation purposes, just for one more data point, if you look at this vector here, right, this radius, right, I would have an x component in this direction, right, and I would have a y component in this direction, right? So this vector here breaks up into some, so this is radius, I'm going to call it r. This would be radius x and radius y, right? So what would be the sign of this component? Well, it's pointing up, so that's going to be positive. And this guy's pointing in the negative x, so that guy will be negative. So you'll get r equals positive rxi minus ryj. Okay? All right, so that's two examples of two of the vectors. For this guy, the theta, you want to measure it with respect to the x-axis. So that's going to be your theta. And then you just want to do the same thing with the rest of these other bones here for a grand total of 8 for the skeleton. Okay? The goal here is that you become a vector master and that you start seeing vectors in everything. Okay? All right. Hope that helps. Have a